Okay, so we're going to get started with an intro to factoring lesson. Factoring is something that you did in elementary school, so we're going to just review that and get you all warmed up. Remember that the factor of an integer is any number that multiplies evenly into that integer. Okay, so for example, the factors of 24 are. What we're going to do is write 24 in the top of our t-chart here, and then down the side we're going to write all of the different factors. If you don't know what the factors are, you can use a calculator. I'm going to start by typing 24, and the very first one to do always is 1. So I'm going to say 24 divided by 1, and I can see that it comes out to a whole number. So I know that 24 and 1 are my factors. So I'm going to put 1 over here. 24. 1 times 24 is 24. Let's do another. 24 divided by 2. This also comes out to a whole number. So I know that 2 and 24 are my next factors. 2 and 12. Let's do 3. This is also coming out as a whole number, so I have 3 and 8. Let's do 4. 4 and 6. We can try 5. 5 does not come out to a whole number. We have a decimal here, so we cannot include it. And as you can see, we're counting up our left column here. 1, 2, 3, 4, and I just tried number 5. I could try number 6, but look, we have rounded out to the other side of the column, and now we'd be making our way this way. So we have now done a full loop. We are good to go. Okay, so I've counted up as far as I can, and now that the factors, there's nothing in between 4 and 6 that I can go, I have done a loop and I have come all the way back. It's a full U-turn. Those are my factors. Remember that the greatest common factor, okay, we call that the GCF, is the largest number that divides evenly into an integer. Okay? Or set of integers. So let's see some examples here. 30 and 25. We are looking for the greatest common factor between those two things, so we need to start by listing off all of their factors. Let's do the number 30. 1 goes into 30, 1 times 30. 2 times 15. 3 times 10. 5 times 6. Okay, now we can see we're coming down over here. 4 is not a factor of 30. Let's do 25. It's always 1 and 25 is the first one. 2 does not work. 3 does not work. 4 does not work. 5 does work. 5 times 5 gives you 25. Okay, so now we have to look for the largest number between these two tables, and I can see that the largest number that they have in common is 5. Therefore, 5 is my greatest common factor. Let's do 40 and 12. I'm going to start with the factors of 40. 1 and 40, 2 and 20, 3 does not go evenly, 4 and 10, 5 and 8, and 6 and 7 don't work. Let's do number 12. 1 and 12, 2 and 6, 3 and 4. We look for the greatest number between those two columns. In this case, it is 4. So 4 is my greatest common factor. Let's do 2 more examples, 36 and 60. I'm going to start with 36. 1 times 36 is 36, 2 and 18, 3 and 12, 4 and 9, and then 6 times 6. Let's do 60. 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10, 7, 8, 9 don't go in, and so we're done here. I now need to look at the largest possible number, and in this case the largest number in both tables is going to be 12. So 12 is my greatest common factor. Now let's do 26 and 50. Okay, we're going to list them for 26 first. 1 and 26, 2 and 13. 26 doesn't go into 3 or 4. As a matter of fact, nothing else. So we're pretty well done here. I can do 50 as well. 1 and 50, 2 and 25. 3 does not go in, 4 does not go in, 5 and 10, 6, 7, and 8 also don't go in, and then we are done. I'm going to compare the two here, and there's not a big number. 2 is actually the only number that they have in common. That is the greatest common factor, is 2. Now, you can do greatest common factors also using variables, and that's where this comes in for grade 12. There are two things that you need to consider when you are factoring. First, you need to look for which variable is present in every single term. Second, you need to look at the term that has the fewest amount of that variable. This is the amount that we are allowed to factor out. What you need to be asking yourself is what can be factored out from all of these terms? What do all of these terms have in common? Let's do level 1 here. I am just looking for what all of the terms have in common. Here, in my very first example, I have an x, we'll do x in green, and I have y. Okay? I have an x and I have a y. Next, I have a 4, that's a whole number, and I also have a y. Okay, now I have an A, B, C. We'll do A in blue. We'll do B in dark blue. We'll do C in fuchsia. And then I have a Y in orange. So you can see that the only thing that these three terms have in common is a Y. So I'm going to go ahead and say that we can factor out the Y. Okay, let's do our next example. I have an x squared and y, a and x squared. What do these all have in common? They all have an x squared in them. So what can I factor? X squared. Our next level here, we need to think about that second step. Okay, we can see we have x's across the board. I have an x, x cubed, and x squared. Which term has the fewest amounts of that variable? So I can think here that this is 1x. In my next, I have 3 x's. It's x to the power of 3. In the next one, I have 2 x's. So I need to say which term has the fewest amount. I have 1, I have 3, and I have 2. Well, 1 is the fewest amount, and therefore that is how much I can factor out. I can only factor out 1x. Let's look at our next example here. Z to the 5, so I have 5 z's, 6 z's, and 4 z's. Which is the fewest amount? Well, 4 z's is the fewest, so I can factor out z to the power of 4. Let's level up here. Let's look at multiple variable scenarios where you could be factoring out several different variables. Here I have a z, a y, and an x. Here I have an A, an X, and a Y. Here I have a B, a Y, an X, and an A. I need to look at what all of these terms have in common. Well, I can see right off the bat that they have a Y in common. Everybody has a Y. I can also see that everybody has an X. So I can also factor out an X. I have a Z in my first term. Nobody else has a Z, so I cannot factor that. I have an A in my second term and an A in my third term, but I don't have an A in my first term, and so I cannot factor that out. And just like in my third here, I have a B, but nowhere else is a B, so I cannot factor that out. Let's do another example. Here I have A, B, C squared. So there's two C's. A, C, D, B. 3AB squared. Well, I think we can agree right off the hop that there's definitely one A in every single term. So I can factor out an A. We can also see that there are some B's that we can factor out. There is at least one B in every single term. So we can factor out a B, and we also need to ask ourselves how many B's can we factor out? I have one B, and two B's. So if you remember step number 2, which term has the fewest amount, I need to look at the fewest amount of B's, and in that case that is 1B. The smallest amount is 1B, so I'm just going to leave B there. And let's look at our third example here. D, A cubed, B to the 4. C, A to the 7, B cubed. And A to the 5, B to the 8. Once again, I think we can agree that there is an A, at least one A, in every single term. And I'm looking for the smallest amount of A's, the fewest number of A's. I could have 3 A's, 7 A's, or 5 A's. The smallest number is 3 A's, so A to the power of 3, 3 A's, is the fewest number of A's that I can factor out. We can also agree that there are B's in every term. Once again, we need to look at the smallest number of B's that are available. Here I have 4 B's, 3 B's, and 8 B's. Which one is the smallest? Well, 3 B's is the smallest, so I'm also going to take 3 B's. That's what I could factor out. And last but not least, let's talk about examples where we have both variables and numbers. You might need to use a factor table on a separate sheet of paper if you need, okay, if you are finding that there is some difficulty with finding all the different factors. I'm not going to do that here, I'm just going to write them out immediately. First things first, you need to factor out the number. We need to find what number that they have in common. 8, 16, and 12. The greatest common factor that they have is 4. Next, I need to look at my variables. I have ABC, ACD, and A. All 3 terms have an A, so I can factor out an A. There are no other variables that are present in the rest of the terms, so I am done. Let's look at our next example here. 10x cubed, 25x squared, and 20x to the 4. First, I need to think about what can I factor out just from the numbers. Between 10, 25, and 20, my greatest common factor is 5. Now I need to look at my variables. I have x cubed, which means I have 3 x's. X squared, I have 2 x's. And x to the 4, so I have 4 x's. There are x's in all of the terms, so I know I can take at least one x. And I'm going to say which one has the smallest number of x's. Well, the one in the middle here, x squared, has the smallest number. There are only 2 x's. So I can take out 2 x's from everybody. Here, let's look. I have 9a squared b, 3a cubed b to the 4, and 21a cubed b squared. First, I'm going to look at the numbers. 9, 3, 21. The number that they have in common, that's the biggest one, is 3. So I'm going to factor out a 3. I can also see each term has an a, so I factor out the a. I need to see how many a's can I take. Well, I have 2 a's, 3 a's, and 3 a's. Well, the smallest number there, the smallest quantity is 2 a's, so I can at least take 2 a's from every single one. Let's look at b now. Is there a b in every term? There's a b here, and b here. So I can also take out a b. I have 1 b, 4 b's, and 2 b's. What's the fewest number of b's I have? 1. So I'm going to leave it as 1b that I can take out. Finally, let's look here. I have 4a to the power of 3, c to the power of 4, d. I also have 12a squared and 20a to the power of 3, b, d. First, I need to think about the numbers. 4, 12, 20. What can I take out from there? Well, I can take out a 4. There's also an a in every term. And now I need to figure out how many a's I can take. I have 3 a's, 2 a's, and 3 a's. I can take at least 2 a's from every single group. C, well, C is only present in the first one, so there's no way I can do that. D is in both the first and the third one, but I can't do that because it's not on the second one. And B is only in the last one, so I'm done here. I can take a 4a squared from every single one of these terms. And that's it.